Assalamualaikum, hello viewers. Today I have come with a new topic which is quadratic equations and functions, and I will discuss first. I will discuss with some formulas from this topic, and then I will discuss with you some problems from this chapter. Okay. So let's start. So first we see the definition of quadratic equation. What is quadratic equation? A quadratic equation is an equation which involves terms up to the second degree, right? So this is a quadratic equation. Here, what is second degree? Degree is the power of x. So the highest power of x in this equation is called degree. So this we see that here highest power is 2, so it is second degree quadratic equation. So we can transform the equation through this way. First we divide both sides by a, then we transform it to the formula, a well-known formula, which is a plus b whole square, through this way. And then after that we get the value of x is minus b plus minus root over b square minus 4ac divided by 2a. Here the b square minus 4ac, this part is important because it is called discriminant of the equation. Through the nature of this part, the value of this part, b square minus 4ac, will determine the nature of the value of x. We will see in the next page, like if this b square minus 4ac, this b square minus 4ac, when this discriminant b square minus 4ac is greater than 0, then the equation has two real and unequal roots, or two real and distinct roots. And when this b square minus 4ac is equal to 0, roots of the equations are real and equal. And when b square minus 4ac less than 0, the equation has complex or imaginary roots. Now if we can say that this equation x square plus bx plus c will be a function which is called quadratic function when a not equal to 0, and the value of a determines the nature of the turning point when we sketch the any graph of this equation. When a greater than 0, the graph of this equation will be like this, and there will be a turning point of that graph. And if a less than 0, then the graph will be like this, and turning point will be the upper maximum value, and here the turning point will be the minimum value. Now we are going for some problems. Here we are having a question. Here we have to show that the equation x square plus 3x plus 2 always has real roots. So now first we see, if we compare this equation with the quadratic form px square plus qx plus r is equal to 0, we find that p is equal to a square, q is equal to 3, and r equal to 2. And the determinant of this equation, we know that q square minus 4pr. So now we know that the value of determinant will determine the nature of the roots of the equation, right? So first we have to find the value of determinant k square minus 4pr, which is a square, and since a square greater than or less 0, so which implies q square minus 4pr greater than or equal 0. That means the roots are always real. We know that determinant, if determinant greater than or equal 0, then roots will be real, which I discussed before. Now problem 2, here is our problem 2. Here Now problem 2 says the quadratic equation x square plus px plus q has roots minus 2 and 6. First we have to find the value of p and q, then we have to find the range of values of r for which the equation x square plus px plus q equal to r has no real roots. So first we see that we are given x square plus px plus q and the roots are minus 2 and 6. So since the roots are minus 2 and 6, when x is equal to minus 2, we can substitute the value of x through minus 2 here. We can put the value of minus x is minus 2 in this equation. So from that we get minus 2 whole square plus p into minus 2 and plus q is equal to 0. Then the value of q will be 2p minus 4. Similarly, if we put the value of x is 6, then we get x square 6 square plus p times 6 plus q is equal to 0, and the value of q will be minus 12, and p, the value of p, thus we get the value of p is minus 4 and value of q is minus 12. Then second part of the problem. For the second part, we are given x square plus px plus q is equal to r, and first we compare with the here. First we have to transform it a little. We have to bring the r to the left hand side from right hand side, and if we compare with this equation, we get the value of a is 1, b is equal to minus 4 and c is equal to minus 12 plus r. Since the roots are not real, so the determinant b square minus 4ac less than 0, because we know that if the determinant are less than 0, then the roots of a quadratic equation are not real. So from this b square minus 4ac from less than 0, from this equality we get the range of r, which is 4r less than minus 64. Then from that we get r less than minus 16. So required range is r less than minus 16. This is now we are going for the another problem here, problem 3. Here in problem 3, we have to express this quadratic equation in the form y is equal to 4 times x minus p whole square plus q, where p and q are constants, and we have to find the minimum value of y. We are given the value of y is this equation. That first we have to transform this into through this way. We first see here, first we take common 4, and if we take 4 outside of this bracket, then we get x square minus 3 by 2x and plus 7 by 2. Now we have to transform this to a minus b whole square formula. So because of that, we bring 2 here, and since we bring 2 here, we can write this 3 by 2 by 3 by 4 times x. Then for transforming to formula, we write this through x square minus 2ab plus 3 by 4 whole square, that is a square minus 2ab plus b square. So 3 by 4 whole square is a extra term here, so we have to subtract it. Why we do this? Because we have to transform, we have to bring this to the form of a minus b whole square. So now we get the a minus b, that is x minus 3 by 4 whole square, and this extra term we bring this to bracket. Now if we see it, if we take minus here, and in the numerator 9 minus 56, that will be minus 47, and minus times minus, which is plus, and it becomes 47 by 16, and we get our required form, which is 4 times x minus b whole square plus q. We bring it to our required form, and here x minus 3 by 4 whole square is greater than or equal to 0 for all values of x. So if it is greater than 0, and then 4 times this expression all will all also be greater than or equal to 0, and this whole expression also be greater than or equal to 0, and that's why the minimum value of y will be 11 and 3 out of 4. Since if we see that is this part, if this part will be 0, then the minimum part will be this mixed fraction, and that's our solution for this problem. Now, so we see another problem of similar type. Here we have to transform this quadratic equation in the form a minus b x plus a minus x plus b whole square, and then we have to find the range of x. First we transform through similar way. We take minus outside of bracket, and then we bring it to a plus b whole square formula. Here um, we have to transform minus 8 to 9 minus 17, because of our since so that we can bring it to formula form. Then we make find that minus x plus 3 whole square plus 17, and which will be 17 minus x plus 3 whole square. Here x plus 3 whole square greater than or equal to 0 for all values of x, we know that. And since this is greater than or equal to 0, minus x plus 3 whole square will be less than or equal to 0, and 17 minus x plus 3 whole square will be less than or equal to 17. And that means if a function of x, the function we let it we let that f of x is equal to 8 minus 6x minus x square, which is our given function, and this given function will be less than or equal to 7. So this is my discussion for today. I have tried to discuss the basic from quadratic function and equation, and show you some problems. I hope this will benefit you, and if you are benefited from my if my discussion will help you, please try to support me, subscribe my channel, YouTube channel, and hope you all the best, and thank you.